Number 18 is where we begin the longest section of the test. It's broken up into two miniature sections. First 4 or so are just factoring problems. And then the last 3 are factoring, but really we're looking for the zeros. This is part of that first section. Number 18 says factor each completely. That is a very tricky set of directions. Because factor each completely can mean a lot of different levels of factoring. Some of them could be just a GCF. Some of them are going to be a trinomial that you break apart. Some of them will be a combination of those two. Some of them might be a special case problem, might be a special case problem with a GCF. There's lots of different levels to factoring problems. But we start off the same. We want to get it in standard form, meaning the trinomial is in order. There's a 0 on the other side if there is a 0. And then we want to try to factor out a GCF if we can, because it makes the problem easier. Up here I see 10 into the 5th power. Right here, that automatically starts weirding me out. That's not how we factor. We don't factor with things to the 5th power. That's just a little alarm going off in my head saying, that doesn't look quite right. And I used to a 5th power being there. We're used to seeing a squared there like we see on 19. So well, let's keep on going. 10, 2, in, and 2. I look at those and say, okay, they're all even, meaning I can at least take an even number out, a 2. But I want the greatest common factor, so I think, okay, what's the largest number? And it is just 2. If I take a 2 out of all of those numbers, it goes out front. Well, what about variables? Remember, we want to steal these variables evenly from everything, meaning they've all got to have a variable if I want to take a variable away from all of them. Same thing with the numbers. They all had to be divisible by 2 for me to be able to divide a 2 out. Well, this has 5 n's. That's a lot. This has only got 1. And this one has none, meaning we can't take an n away from everything. So 2 is the only thing dividing out. Now it's just damage control. What do we leave behind? 10 divided by 2 is 5. Into the 5th power has to stay. 2 divided by 2 is 1, so this is just in. And 2 divided by 2 is 1, so it's just plus 1. Next, our instincts kick in and tell us, okay, find factors of 5 that can add to be 1. And you can try that all day, but you're not going to find them. Not to mention what I talked about earlier. This little to the 5th power messes things up as well. Turns out, this was just a GCF problem. All you could take out was a 2, and you had to leave everything else in there alone. It's tricky. That's really hard to know that you're actually done right there. Because then you immediately get on a problem like number 19. Number 19 has a lot of numbers out front that are all big even numbers, and I'm looking for the highest thing I can take out of all of them. Gut reaction, I know I can at least take a 2, but I think I can take something bigger. Well, I know that 4 goes into 16, and 4 goes into 12, and 4 goes into 40. So then I start thinking higher. What about 6? Well, 6 doesn't go into 16. What about 8? Well, 8 doesn't go into 12. 10's not going to work. 12's not going to work. Turns out 4 is just the highest number. So we take a 4 out. We look at the variables, x squared, x, and no variable at all. This one's stopping us from taking any variables out. So we're just going to be okay with the 4. All right. So we have 4 dividing out, which means we have 4x squared plus 3x minus 10. That's my new trinomial. I'm looking through the answers because I always forget this 4 in my final answer. So I would make sure that anything that didn't have that, I would get rid of. And next we're doing our factoring process. Our next step in factoring was to multiply the front and last terms of our trinomial. That's negative 40x squared. We need factors of that can combine to be our middle term of 3x. Well, I'm not really good with my times tables, so I'm going to show you the calculator trick for how to find factors. To find factors, we go into our graphing section, clear out whatever's there. We're looking for factors of 40, which means I want to divide 40 by 1, by 2, by 3, by 4, by x, because that'll do it for us. When we look at the table, we see, of course, divided by 0 gives us an error. 1 times 40, 2 times 20. 3 doesn't go into 40. 4 times 10, 5 times 8, and then when you see the ones flipped upside down like this, it means you've gotten to all of them, because we already had 5 and 8. It's the same as 8 and 5. So now I just run through the list and I think about in my head, could I add or subtract them and get a 3? 40 and 1 add to be 41, subtract to be 39, it's not a 3. These add to be 22, subtract to be 18, not 3. These add to be 14, subtract to be 6, so we're getting close, but it's still not a 3. These add to be 13, subtract to be 3. So those are our numbers, 5 and 8. So 5x, 8x. Now let's make them fit both puzzles. Again, 5 and 8 actually combine to be 13, not to be 3. So we got to make one of them negative, because that also will help solve this issue. To multiply two numbers together and get a negative, one of them has to be negative. In this case, it needs to be the 5, because we need the addition to work out and give us positive 3. Once we've done that, we have all the pieces we need for our box method. Our first term was 4x squared. Our last term was negative 10. The found pieces in the middle were negative 5x and 8x. We get a 4x across the top row. We get a 5 across the bottom row, and because that's negative, it makes that one negative. We get an x here. The largest number we can take out of both of those is a 2. This is positive, so that's positive. And now is when I double check to make sure it all multiplies back in correctly. 4x squared, good. 4x times 2 is 8x, good. Negative 5x and negative 10, good. Thus, my final answer should be my 4 that I started off with times x plus 2 and 4x minus 5. Oh, close. Got the signs backwards. X plus 2, 4x minus 5. Again, though, guys, check them, check them, check them. 16x squared plus 12x minus 40. My final answer is 4x plus 2, 4x minus 5. Original coming in now. Can't even see all of it, but that's okay. We just want to make sure the second equation isn't different. Next one coming in, I never saw another parabola open up. I never saw some other lines coming through over here. Mine changes colors, which is really, really nice. But you're just looking to see if another parabola accidentally rears its ugly head. 20 and 21. Man, I love problems like number 20 because I get this one all the time from kids that don't know what they're doing. They're like, not factorable. It's a weird problem. Well, you're right. It's a weird problem, but you can't just jump to conclusions here. This should just absolutely light your head up as a siren. Like something weird's going on. Something's happening. Why has it only got 2 pieces? Not only why does it only have 2 pieces, why are they both perfect squares? That's because this is that very, very, very specific problem type. It's called a difference of perfect squares. I'm going to do a capital B so you can kind of tell the difference between that and 6. 16b squared breaks down into 4b times 4b. 9 breaks down into 3 times 3, or more specifically, 3 times negative 3, but that's the perfect square is 3 times 3. This means when we have this exact setup that we can go straight into our answer. This will be 4b plus 3 and 4b minus 3. Front part in both, back part in both. One's a plus for the positive 3, one's a negative for the minus 3 to get a minus 9. I look through and I see my answer. Again, graph it and check it. Don't trust me, graph it. Our final problem is another one that starts off awkward. I look and I say, okay, that's weird, another x to the 5th power. Doesn't mean it's a GCF problem, but I know that something's got to come out of it. So, I think, okay, numbers. What number can I take out? I can't take a 10 out of all of them because that one's not divisible by 10. So the largest number I can take out of everything is a 5. Couldn't eliminate anything. These all took out a 5. That's good. Variables. I'm looking down here at the answers. I see x squared. I'm like, oh yeah, take x squared away. Guys, you can't take what's not there. And we have to take from all 3 terms. That one has 2 x's it could give. This one has 2 x's. This one only has 1 though. Meaning the highest amount of variables we can take out is a single x. Well, let's see what happened when we did this. We divide by 5 and get a 2. We had 5 x's, and we're taking one of them away, meaning we have 4 left. 10 divided by 5 again is positive 2. We had 2 x's here. We are taking one away, leaving us with a single x. Plus 5 divided by 5 is 1. We had a single x here. We are taking it away, meaning all that's left is 1. This should multiply back in to check your answer. This would be 10x to the 5th power, 10x to the 2nd power, and 5x. Meaning this is my final answer. That one's out, that one's out. 2x fourth, 2x, there we go. Last problem in this factoring section. This one is the one you can't really check in the calculator. The rest of them you could. We have to put a few on there that the EOC puts on there that are not checkable with a calculator. Which of the following would be a factor of 5n squared plus 39n minus 8? We multiply first and last term together because I know there's no like term here. We're looking for factors of negative 40n squared that add together to be 39n. Interestingly enough, it's the same one or the same second problem on here that's had factors of negative 40. I wouldn't bank on that happening. And in this case, though, they are different factors of negative 40. We're going to need 40n and 1n. Well, to make a negative, one of these has to be a negative. Watch this, guys. If I make this one negative, I've now made a negative 39. I don't want that. So it is important which is which. I need this to be the negative because now 40 minus or plus negative 1 is positive 39. Okay? Ready to box it all up. My first term was 5n squared and negative 8, 40n and negative 1n. The only thing coming out here is the letter n. Down here, though, times tables, we know a positive 8 comes out because this is positive, that's positive. Okay? Don't overthink it with this negative down here. It doesn't really have any bearing on the problem. Here, we get a 5n, and right there, we get a negative 1. Make sure it goes back into the box correctly. 5n times n is 5n squared. 8 times 5n is 40n. N times negative 1 is negative n. And 8 times negative 1 is negative 8. That means these are my correct pieces. 5n minus 1 and n plus 8. Oh, almost got me. Oh, almost got you twice. Oh, wait, no. I just got myself. Oh, no. All right. I did exactly what these choices are supposed to make you do. They make you go too fast. They're going to make you X out the wrong one. I looked up here, saw 5n minus 1 and 5n plus 1. Looked back down here at the answers and just went too fast, and I marked that thing out. That's the answer, guys. This is the wrong one. N plus 8, that's the wrong one. That's N minus 8. God, it's very, very, very particular. Be very careful. And then N plus 4 wasn't even in really the ballpark here. You'd get N plus 4 if you didn't take out the greatest common factor here. And if you didn't check to make sure it multiplied back into the box.